What is science? To some, science is a process by which we improve our understanding of reality and of the world around us. Yet, to me, science is more than that. It is also a reflection of our human tendency for self growth and discovery. In this context, something that has always fascinated me is the relationship of science with failure. In science, failure is not just inevitable, it's essential. This is in high contrast with other areas of life where failure is usually seen as a setback or an obstacle and something to be avoided at all costs. I have come to appreciate how failure plays a pivotal role in scientific progress because far from being a burden, it is a very powerful tool which enables us to discover new theories, which fosters innovation and which drives us to ultimately refine our understanding of the natural world. One key concept we have studied that has stuck with me is the one of falsifiability introduced by philosopher Karl Popper, which argues that for a theory to be scientific, it must be testable and hence must be capable of being proven wrong. In many ways, this turns the traditional view of science on its head because what when we think of science, what we usually think of is of something that provides us with irrefutable and absolute knowledge. Yet, rather than providing us with this, what the concept of falsifiability entails is that we have to approach science with a mind of skepticism, of openness, and always with the idea that all the knowledge we find will, in high likelihood, be only temporary and a stepstone in order to reach even higher forms of knowledge. It is through this process of constant refutation and improvement that science advances, evolving over time to become more accurate and refined. In this sense, science and science failure is indeed in the very nature of scientific inquiry, which is built upon testing hypotheses, analyzing results, and often encountering failure. Failure allows scientists to discard inaccurate theories and to form new ones. It is the ultimate scientific benchmark. It's this cycle of trial and error that ultimately leads to a formulation of robust scientific theories. Without failure, we would be stuck in a state of stagnation, in a perpetual state of unchallenged assumptions and theories, and we would also have zero motivation to improve upon our stagnant knowledge since we would see no need to. And this principle is very evident when we look at the history of scientific breakthrough, most notably uh, of what happened when Darwin published on the evolution of species. So Darwin's ideas were, in many ways, a product of failure. His failure to accept the prevailing belief at the time that the world was static, unchanging, and created by God. Before Darwin, there was never any contestation of this possible fact. In fact, it was the common assumption that regulated research in the scientific community. Needless to say, this led to a bottleneck situation where the research were flawed before they even began because they began on an assumption that was wrong. So the notion that life on Earth was not the result of the divine creation, but rather a process of gradual change over a million of years, clashed with religious and orthodox and scientific orthodoxy. And yet, despite the failure of his contemporaries to accept his theory, Darwin's theory has nonetheless gained more and more support throughout time as evidence mounted and piled, and ultimately, it has triumphed over the old view. His theory revolutionized biology. It has founded the field of evolutionary biology and has shown that life was not static but dynamic, shaped by natural forces that continuously tested the survival of organisms and selected them. The initial rejection of Darwin's work was a failure to embrace new ideas, but over time, the truth won. Similarly, quantum mechanics provides another striking example of how failure leads to deeper understanding. In the early 20th century, scientists like Max Planck and Mark Einstein and Albert Einstein were grappling with the limitations of classical physics. Classical theories of matter and energy could not explain uh, a few phenomena that could be observed at the atomic and subatomic levels. Rather than clinging to outdated ideas and trying to tweak one or two things in the theory to make it work, what Max Planck decided to develop his own. And the main difference between his theory and the classical physics, which came to be seen as a revolutionary, is the idea that reality is not deterministic. Because in classical physics, given the initial set of conditions, we can always deduce in which state the system will end as. Yet, what Max Planck found is that Max Planck's theory is founded on the theory of probabilities and on the very idea that reality, at its most fundamental level, is inherently uncertain and random. This has challenged the perception of the world around us, and it has influenced a generation of scientists after him. And even though this theory is incompatible with with classical mechanics, uh, it has still led science to progress. It has still yielded a lot of extremely valuable experimental data and opened up new frontiers. So, which led to advancements in technology and a deeper understanding of the universe. Both Darwin's theory and quantum mechanics emphasize the fact that failure is not just about being wrong, it's about being able and willing to confront our ignorance and to rethink our assumptions at the most fundamental level. In this sense, failure becomes a tool for growth. Science is after all a process of continuous learning, and each failure forces us to question our old belief, to revise our methods, and ultimately allow us to improve our understanding of our world. This semester to me, has shown the truth that fear of failure often holds back, but in science, it is an integral part of success. The greatest scientific breakthrough in history are born out of moments of acknowledgments that we don't know, and we have to uncover new truth, whether through the rejection of old theories and paradigms, or through a refinement of them, or through the development of entirely new paradigms. And hence, failure is a catalyst for progress. So, I would say, in conclusion, that the relationship between failure and success is absolutely central to the scientific enterprise. Darwin's evolution theory, as well as quantum revolution, remind us that progress in science doesn't come from uncertainty, but from the willingness to fail, to challenge old ideas, and to build new ones. Science is not about finding all the answers. It's all about asking the right questions, even if it means failing time and time again before we succeed, if we ever do. Thank you for your time.